Okay, so this is going to be our next lesson over naming alkenes and alkynes. Okay, so we're going to be dealing with pretty much the same rules as what we had for naming alkanes, but there's just one extra step in there. Okay, so the general formula for an alkene is C to the N, H to the 2N. These are going to be compounds that deal with double bonds. These are also known as olefins, and they end in an E-N-E ending. Okay, so alkanes end in A-N-E. Alkenes are going to end in E-N-E. Okay, so we're going to start with the same type of rules. We're going to identify the longest chain of carbons that contain the double bond. Okay, so 1, 2, 3, 4, 5. So that's going to be your longest chain of carbons right there. Okay, and we're going to go through and number it. Now, the difference in the rules for this one and alkanes is the double bond has to get the lowest numbers possible. So we're going to number going from left to right because it would be in the 1 position here, and if we're going this way, it would be in the 4 position. Okay, so this is an ethyl group, just like we did before. So this is going to be 2-ethyl. We have to locate where the double bond is, so it's in between the 1 and 2 carbons, so we say it's 1-pentene. Okay, so this little number right here tells you at what position you're in. If it was right here, it'd be 2. If it was right here, it'd be 3. If it was right here, it'd be 4. Okay, it ends in E-N-E because it's an alkene. Okay, the next one. Little more complicated question. So our longest chain of carbons that contains the double bond is right here. And we're going to number from right to left. So 1, 2, 3, 4, 5, 6, and 7. Now we're going to name our groups. This is a bromo. This is an ethyl. This is a methyl. And this is another methyl. So when we go to name this, it's going to be 4-bromo, 4-ethyl, and it's going to be 6,6 dimethyl dash. Now we have to signify where the double bond is, so it's in the 1-2 position. Okay, so we say 2, and this is going to be heptene. Okay, so it's pretty much the same rules that we did before, just one extra step. Okay, longest chain of carbons right here is 4. And there's no substituent groups, so we just named this 1-butene. Okay, the double bond is in the 1 position. Okay, reminder, if it was right here, it'd be in the 2 position. Right here, it'd be in the 3 position, but it would end up being the same exact thing. So it's just 1-butene. Okay, next example problem. So now we're going to draw the structure for the following. Okay, so just like we did before. Pentene is 5 carbons long. And the 2 position is where the double bond is. So we're going to work backwards. Now we got a methyl coming off the 2nd carbon. And then we're going to go fill in our hydrogens. Remember, the rule is 4 minus 1. I mean 4 minus however many bonds you have. So in this case, you have 4 minus 1 bond is 3 hydrogens. This one has 4 bonds, so we don't put any hydrogens. The next one has 1, 2, 3. So 4 minus 3 is 1. This has 2. And this one has 1, so we write 3, like that. Okay, next example problem, hexene. Hexene is 6 carbons long. Okay, the double bond goes in the 1 position, like that. And then we're going to put a methyl group coming off the 3 carbon. And we're going to put an ethyl coming off the 3 carbon. Okay, they can either go up or down. Doesn't matter which position you're at. Okay, and now we're going to fill in our hydrogens. This has 2 bonds, so we fill in 2 hydrogens. This has 3. 4 minus 3 is 1. This has 4, so we don't write any hydrogens. This has 2. This has 2. And this has 1, so we write in 3. Okay, on to our next type of compound. It's called an alkyne. Alkynes, their general formula is C to the N, H to the 2N minus 2. They're characterized by a triple bond. They end in YNE. Okay, so we name the following compounds. We identify the longest chain of carbons. So in this case, our longest chain of carbons that contain the triple bond goes this way. Okay, you want your triple bond to have the lowest position possible. So when we go to number this is 1, 2, 3, and 4. So this is going to be 3-methyl. This is a methyl group. Sorry, I forgot to write that. 3-methyl dash. The triple bond's in the 1 position, and it's 4 carbons long, so it's butene. So we end in YNE. Now, some people get confused on this. They want to try if they write the hydrogen like this, so I can write the hydrogen like that, or I can go out to the side and write this compound to where it looks a little bit different. That's the same exact thing, okay? So there's no difference between writing it this way and writing the H out to the side. A lot of times when it's just like a H on the end, they write it like this, okay? So you have to be able to go between both formats. Okay, next type of compound, we got this one. So we're gonna identify the longest chain of carbons. So it's gonna go across like this. Okay, we have a chloro, we have a methyl, we have another methyl, we have an iodo. Okay, so we're going to number to where the double or triple bond gets the lowest numbers possible. So if I go this way, 1, 2, 3, 4. If I go this way, 1, 2, 3. So I'm going to number this way. Okay, so when I go to name this, I'm probably going to run out of room, but I'm going to try my best to make it visible for you. Okay, so we're going to go in alphabetical order. So this is 6-chloro. Iodo's next, 2-iodo. And we have 2 methyl groups. They're coming off the 2 and the 5 carbon. So 2, 5 dimethyl dash. The bond is in the 3 position. So 3, and it's going to be heptine, because you got a triple bond. Okay? So there's really no difference between alkenes and alkynes except for the triple bond. Okay, draw the following structures for the alkynes. Okay, so nonine. Non is 9 in a row. 3, 4, 5, 6, 7, 8, and 9. The triple bond is in the 1 position. Okay, you have a methyl group coming off the 5 carbon. 1, 2, 3, 4, 5. And you got a methyl group coming off the 7 carbon. And then you got ethyl groups coming off the 3, the 4, and the 6 carbon. Okay. Now, all that's left to do is fill in your hydrogens. So you have a triple bond right here. So 3 bonds. So 4 minus 3 is 1, or you can write the hydrogen out to the side. 1, 2, 3, 4. No hydrogens. 1, 2, 3. 4 minus 3 is 1. 1, 1, 1, 1, 2, and 3. Like that. Okay. Pentine. 1, 2, 3, 4, and 5. Pent means 5. The triple bond's in the 1 position. And I have a methyl group coming off the 4th carbon. Like that. And we're going to go fill in my hydrogens. This one has 3, so 4 minus 3 is 1. 4, that has 4. 4 minus 4 is 0. 2, 1, and then 3 like that. So this is the end of the alkenes and alkynes practice problems. Just some information about alkenes and alkynes that you might find useful. I had this in an old set of notes. So alkenes and alkynes are super important for industry. They make lots of money. So the first type of reaction that's listed here is catalytic hydrogenation. So you're going to use catalysts like platinum, palladium, nickel, or rhodium. And you can always use dehydrogenation to create alkenes and alkynes, so to create that double bond. So the way that, so this is ethane gas. The way they would dehydrogenate would mean you're going to remove 2 hydrogens and you get ethene or ethylene. And we all should be familiar with ethylene because we live near an ethylene plant. Okay, cracking. So when you crack, you're breaking large molecules into small molecules. You have steam cracking, and you get a lot of alkenes out of that. You have catalytic cracking, which produces branched and cyclic alkanes, which means like your cycloalkanes. And then you have a process called a reformer. Okay, in the oil refineries, they have a reforming unit. Okay, so like in this compound right here, 1, 2, 3, 4, 5, 6. That's a 6-carbon chain, so that's heptane. So if I take heptane and I put it through the reformer, I'm going to get cyclohexane. Okay. Polymers are a giant chain of repeating molecules that consist of repeating units called monomers. Okay. So you know, the way polyethylene is made is these double bonds react with each other and they open up, and that's how you produce high density polyethylene and low density polyethylene. And the reaction continues and continues and continues until you reach a termination step. Other polymers that we're familiar with are nylon 66. SBR rubber is something we've talked about in the semester where, you know, during World War II, they had to come up with another way to make rubber from, you know, rubber trees were being depleted. So they came up with a way to make synthetic rubber. So that rubber that we've talked about is an example of a polymer. Okay, and then polypropylene. Okay, so that's just some facts for you. That's not going to be on your test or anything like that. So hopefully this video was helpful, and hopefully you'll have a good night. Thanks.